Hello, I'm Dr. Theory, and this is Frankie. Today, let's make a hairy grass head. First, draw a face on the cup.
Like this?
Yes, and put some dirt inside.
It's a grass seed on top, that kind that grows in the shade.
Yes, and make sure you water Harry every day for the seeds to germinate and grow. Frankie, let's put Harry into Mr. Time.
Yeah!
All righty, time machine, open. All right, let's transport Harry into the future 2 weeks. Watch the clock as it's going clockwise. All righty, that's about 2 weeks. Time machine, open.
Look! Harry has hair!
Harry needs a haircut. Come here, little buddy. All right. Hello, I'm Dr. Theory. A one-dimensional world is just a line, like this ruler and this laser light beam. A two-dimensional world is a flattened surface. When you turn it to the side, it disappears. A three-dimensional world is space or volume, like solids, liquids, vapor, and plasma. My mission is to travel into the fourth dimension, to travel in time. Back when I was 3 years old. Open.
The fourth dimension is time!
Let's experiment with air pressure. First, fill up a cup with water. Then, place a plastic lid from a coffee or butter container on top. Now, hold the lid on and slowly turn the cup over, and I know that when Frankie lets go of the lid, the water will not fall out. Here's why. Because of the air pressure on the outside and the vacuum. The sucky air inside together hold the water in. Frankie, you can do this one over my head because I know the water's not going to fall out. All righty, are we ready? And let go!
Air pushes everywhere.
Yes, and next time I'll show you a trick where you put a hole at the bottom of the cup and you... Frankie, did you put a hole at the bottom of the cup?
Yes, transfer!
This is the Cartesian coordinate system with the x-axis, y-axis, and z-axis. And this is the origin. Frankie, ready for transport to the origin where all points is 0. All right, transport to x equal 3. Y is equal to 4. All right, now z plus 2. Yeah, all right. In this coordinate system, we have the negative z-axis. Frankie, transport to x equals 3, y is equal to 3, and z is equal to negative 3. Let's beam Frankie into the floor. Transport!
Transport, please.
Z plus 3. This is my coordinate system, my reference frame. Over here, Jake is holding Frankie's reference frame, his coordinate system. Jake, let's invert it over and beam Frankie in upside down. Let's see what happens. Frankie, transport to x is equal to 2, y 2, and z 0. Transport! Frankie, what's the acronym for laser?
Light application by stimulating emission of radiation.
Exactly. Turn the power on to a low 3 milliwatts. This is a gas-powered laser. Inside this tube are special gas atoms that get real excited when they're charged with electricity. Thousands of volts of electricity. These atoms release or emit energy in the form of light everywhere. This light bounces back and forth between these two mirrors, building up or amplifying their energy. This special mirror lets out some of the light to make a laser beam. Frankie, goggles on. Turn the power on to a low 5 watts. No higher to burn a hole in this paper. Whoa, Frankie, did you burn a hole in my wall? Frankie, try to slide, not roll the water balloon on top of the wax paper.
Not so easy because it's friction.
That's right. Zoomer, transport. This is Zoomer. He can magnify like a microscope and show us what causes the friction between the balloon and the wax paper. Zoom in, Zoomer. Now magnified, we see the molecular surface of the balloon, and the wax paper is not so smooth. Closer, Zoomer. These are the contact points where these molecules are sort of glued together. That's why it's hard to slide. Zoom out, Zoomer. Transport. Add vegetable oil and the atoms lose their grip.
By reducing the friction, off it slips.
What is the force of friction?
A push upon the other direction.
Yeah. Inside a magnet, there are these special spinning electrons. These electrons orbit around the atomic nuclei. Moving electrons create lines of force called a magnetic field that come out of the North Pole and into the South Pole in a loop-de-loop. The Earth is like a big magnet. This is the northern hemisphere, the northern geographic pole of the world, where the magnetic fields enter into the Earth. Therefore, it's the south pole of a magnetic field. A compass is a magnet in the shape of an arrow. The north pole of the compass is attracted to the south pole of the Earth's magnetic field. Remember, unlike poles are attracted together. Where's Frankie anyway? Frankie? Frankie, did you find him? Excellent. Ready for transport?
Whoa, I must be dreaming.
Hello, Benjamin Franklin. Welcome to the future. I'm Dr. Theory. Today's subject is electricity.
Electricity, my favorite subject of all. Frankie, did you know that electricity comes from the word for amber? They used to rub the rock amber and a small spark would appear, and they called that electricity. However, I was looking for a different kind of spark. If I could possibly bring lightning down and put it into a Leyden jar or a battery, then I could test it and see if it was electricity, just like the kind we make by rubbing glass.
You can borrow my kite.
A kite, a wonderful idea. You know, if I had a kite, I could run it up into the heavens, a kite. And then I could bring the string down to a jar. I could do it. I'm ready to wake up now.
Thanks, Benjamin Franklin. Time transport 1746.